and find the exact values. All right, so you want to draw this on your Cartesian plane. So that's in the fourth quadrant, right?
Yeah.
And 1/6 is bigger than 1/8. So that means it goes down more than it goes up. So it's got to be bigger than -45 or, bigger absolute value.
hmm
Right. So this is -1/6. This is +1/8. And then this is your hypotenuse, H. So I feel like we did this once before, didn't we? Where we have to try to solve this equation. 1/8 squared plus -1/6 squared equals H squared.
hmm
And didn't we talk about how there's like might be a trick for doing this? I feel like we talked about that.
Yeah. But like when I was doing a review, I was doing like these exact same steps, but then they would come out something completely different. So it would
That's
have the radius, or like I would have the H as it is, but then when they wanted me to look for the cosine, it would be like 3 times the square root of 73 over 73, which I was very confused when I
okay. Well, let's just go ahead and do this. Okay.
yeah.
So this would be 64 is just 2 to the 6th power, and 36 is 6 times 6, so it's 2 squared and 3 squared, right?
hmm
So that means that I need to multiply this over here by 3 squared on the top and the bottom, and I need to multiply this up here by 2 to the 4th on the top and the bottom.
hmm
See what I'm doing there? And that will allow me to get common denominator. So I get 9 plus 16 all over whatever 9 times 64 is. I'm just going to write 9 times 64. Okay. Do that right.
hmm
So that's 25 over 9 times 64 equals H squared. So if I take the square root of both sides, H equals 5 over 3 times 8, which is 5 over 24. Okay.
Okay.
So 5 over 24 is your hypotenuse. So the sine of that angle, this is your angle there, would be the opposite, -1/6 over the hypotenuse, 5 over 24. So multiply by the reciprocal, cancel out. So that's 4. So -4/5, right?
hmm
And that would mean that the cosecant,
Would be 5 over -4.
-5/4. So we got those two. Whoops. Okay, the cosine of that angle is going to be the adjacent 1/8 times the reciprocal. Cancel, cancel, 3. That's 3/5. And the secant would be 5/3. Right? So the tangent was the one you had the hard time with?
Yeah.
The tangent is the opposite over the adjacent, which is, so multiply that by 8 over 1, and those cancel, and you get 3 here, and you get 4 there. So -4/3. The cotangent is -3/4. And you're saying that's not what they gave you?
Yeah. Let me see if this is yeah. Um I have the photo a screenshot of it right here. Like I was very confused, like why suddenly from 3 over square root of 73 turned into
I think that is just the wrong problem that they're looking at somehow. You know what
is.
I'm saying? I feel like they just gave you the wrong. They're giving you a point where it was -8 comma 3. So they're doing it like it was this -8 3 right here. -8 3. And so this radius right here, the h, would be the square root of 64 plus 9, which is the square root of 73.
Mm-hmm.
That's what they must have just been looking at the wrong problem, because it clearly this isn't even in the same quadrant as this.
Yeah. Well, this screenshot, the second one is a different question. I was just trying to show like what was the problem I was having, and I was wanted to clarify.
Yeah, this one we have right here, you don't have any radicals. It makes it a lot easier.
Mm-hmm.
For this, if they gave you this problem right here, it's -8 comma 3, then your radius or your hypotenuse is going to be square root of 73. So
Mm-hmm.
then the sign would be um, the opposite over the hypotenuse. And then they're just rationalizing the denominator. Is that what you're confused by?
Oh.
To go from that to their final answer, they just multiplied by √73 over √73. That's called rationalizing the denominator, because a lot of times they don't want you to have a radical in the denominator.
Oh,
That's
okay.
all they're doing. But for our problem, there was no radicals to even worry about.
Okay. Got it.
Okay,
Mm, yeah.
got another
Um,
one.
yeah. This it's another one that we talked before, but I can't recall how to do it.
Okay, show me what you're thinking. Show me how you're doing it to start.
Okay, so where is the pen? So the two pulleys, one with a radius of 2 inches and the one with a radius of 8 inches. If the 2 inch belt is pulled by 3 revolutions per minute, determine the revolutions per minute of the 8 inch pulleys. Hint, the linear speed of the pulleys are the same, both equals speed. So what I would do,
That's the key right there. The linear speed is the
yeah.
same.
So first I would do the 2 inch, oh, that's a thick line. Um, I would do like the two pulleys, one with 3 revolutions.
Okay.
So 3 revolutions per minute. And I know to turn this into radians.
Yeah, so we're gonna turn that into, we're gonna go from this to linear speed, and
Hmm.
then go from linear speed to angular speed for the other one.
Yeah,
So that's the key. That's the plan.
that would be 6 pi radian per minute.
Mm-hmm.
So we take this and then we multiply it with the appropriate radius.
Yeah, so now we want to convert it back to revolutions per minute.
Do we need to do it or do we just, well, I thought we were supposed to do like after you set this in, you put it to this, and then from here,
Hold on. You're missing something here. One revolution is 2 pi r. So
yeah,
you're missing the radius. 2 pi times the radius. And what was the radius?
2.
Right. So this would be 4 pi.
Really? Oh,
Yeah, because what's one revolution equal to?
up.
2 pi r is one revolution,
Okay.
not 2 pi.
Well, I just thought because like 2 pi was already like a full circle or. in radians.
It's 2 pi radians, but remember, we're talking about what's one revolution equal to in terms of distance.
The
We're trying,
circumference.
yeah, one revolution is a circumference basically,
Mm,
because that's what linear speed is. Linear speed is this is 2 pi radian. Um, well, another way to think about it here, maybe this is easier to think about it. Don't think of it like you're saying. Think about it as how much is one revolution, because we're trying to convert it to linear speed. So we're how many inches is in one revolution?
if the radius is 2,
It's the
then
circumference,
yeah, then
the
it would be
circumference. So 2 pi
4.
times 2. Yep, it's which is 4 pi. So this is 12 pi.
Okay.
And it's not radians per minute, it's inches per minute.
Okay.
See, that's what we're trying to do. We're trying to convert it to linear speed and then
Hmm.
take the linear speed that we have and convert that to angular speed for the other pulley. You know what I'm
Okay.
saying?
Hmm.
Does that
And
make
then
sense?
from there,
Yep. So this is 12 pi inches per minute. And now let's convert that back to revolutions per minute for the other pulley. So what's 1 inch? Notice I'm putting inches on the bottom now to
hmm,
cancel it out. And what's one revolution in terms of inches for the bigger pulley?
8 inch.
It's
So, but
two pi times 8,
so that would be 16.
right? So that equals 12 pi over 16 pi. The pi's cancel out. 4 cancels out of both of those. You get 3 over 4. 3/4 revolution per minute.
Okay. That makes much more sense.
So the one is revolving 3 revolutions per minute, and the other one's revolving 3/4 revolutions per minute
Okay.
because it's much bigger. So it's going slower, like gears on a bike.
Hmm.
Does that make sense how we do that?
Yeah.
So the mistake you made is that you were thinking that 2 pi equals 1 revolution, which is true if you were just talking about angles, but we wanted to convert it to linear speed.
Okay.
So really, this is the circumference is what we're looking for. What's the
Got it.
circumference? Make
Okay.
sense?
Hmm. So, like, my biggest problem with this unit is the unit convergence. Like, I know how to do the math. It's just the convergence of units, like hours, minutes, seconds, miles, feet, inches.
Mm-hmm.
That's the problem for me with these questions, and that's why I get them wrong.
Hmm. Do you have to have all that stuff memorized and you're having a hard time memorizing it or what?
Yeah, I've been trying to like memorize like for miles to feet, 5,280 feet is 1 mile. I don't know how like the rest of the class memorized it, like, but they somehow did, and he just like skipped past it.
Yeah. I would say go to like Quizlet or something like that and just find like you know, conversion factors for pre-calculus or conversion factor for algebra trig or something like that. Conversion factors for trig, and
Hmm.
then look for something that's where they just give them to you and just kind of keep drilling yourself, or just make flashcards
Okay.
because yeah, you just kind of have to have those memorized. if he doesn't
Mhm.
let you use a cheat sheet, which sounds like he's not.
Yeah, he doesn't allow us to use cheat sheets.
Yeah.
There was just one more question. I know that there's a question that I know is difficult, but I can't find it online.
Mm-hmm.
It's like if x equals 2, and then put this into a equation of x plus y equals 1. This would be for like the sine and cosine. Find the sixth trig, and I couldn't figure out how to do it.
I'm not sure I understand the question.
I'm describing it very badly. I just can't find it in my Google Classroom.
So it was a system of equations or no?
Um, trying to remember. It was something like that, I think. Hopefully I could find it. Um, if not, I could try searching for it tonight, and I think I have an in-person session tomorrow, and I could bring it tomorrow if I find it tonight or with
Yeah,
my teacher.
why don't you do that? Because I'm not sure that I remember that.
Yeah.
Plus we're almost about done now anyway. So if you don't remember
hmm
what it is, we can
hmm
talk about it tomorrow.
Yeah. Okay. I think that's all I have for today.
All right, sounds good. Nor, you have a good night. Hope you're feeling better
Thank
soon.
you. Thank you.
All right,
Have a good
see ya.
night.